Hello viewers, welcome. This is lesson 2 on the simple electrical circuit. We did some amount of work in lesson 1 regarding this particular question. We were able to find the effective resistance for the power connection and then the total resistance for the circuit. We're also able to find the total current flowing in the circuit, and we also found the potential difference across the power connection. Current 1, 2, and 3, yes, we found their values. We added those 3, and then we realized that they are equal to the total current flowing in the circuit. Alright, so in lesson 2, what we want to do is that we want to find the potential difference for resistor 4, 5, and 6. So if we find their potential differences and we add to the potential difference across the power connection, what we expect is that the sum of all these potential differences should be equal to the sum of the EMF in the circuit, which is provided by these two batteries. So if we do the right thing, that should be the result that we should be having. So without much ado, let's get into action, right? So in lesson 1, we found the potential difference across the power connection, and then we labeled it as V1. So V1 is 1.213 volts. That's V1. So what we've got to do is to find V2, V3, and V4. If we do that right, as I said earlier, their sum should be equal to the sum of the EMFs in the circuit. So how do we go by finding the potential difference across resistor 5? Now, the potential difference across resistor 5 is what we have labeled as V2. That's our V2. So V is IR, right? And our resistance here is referring to resistor 5. So resistor 5. The current that is flowing in the circuit, I, is 1.25. Now, this multiplied by the resistance of our resistor, which is 3 ohms. So what does that give us? Here we have 3.75 volts. So 3.75 volts. This is the potential difference across resistor 5. That's our V2. Now our V3, the potential difference across resistor 4. Alright? So V3 IR4. So the current multiplied by the resistance of resistor 4. So the current 1.25 ampere multiplied by the resistance of resistor 4, which is 2 ohms. So what does that gives me? That gives me 2.5 volts. So I have 2.5 volts. Alright? Then where do I go next? I go to the potential difference for resistor 6. That is labeled as V4. So that is IR6. The current multiplied by the resistance of resistor 6. My current is 1.25. And of course, the resistance of resistor 6 is 2 ohms. That also gives me 2.5 volts. Okay? Alright. So now, I have 4 potential differences. Despite the fact that I have 6 resistors in the circuit, I have 4 potential differences. So why is that so? Why is it that I have 6 resistors but 4 potential differences? It is so because 3 of the resistors are connected in parallel. And for that parallel connection, they have just 1 potential difference, which is V1. So all these 3 have V1. So we are now left with 3 resistors. So resistor 5, resistor 4 here, and we also have resistor 6 over there. So each of them has its own potential difference. So that's what we've done. Sorry. So resistor 5 has got a potential difference of V2, which is equal to 3.75. Resistor 4 has got a potential difference V3, which is equal to 2.5 volts. And then resistor 6 has got a potential difference V4, which is equal to 2.5 volts. So the sum of all my potential differences V is equal to V1 plus V2 plus V3 plus V4. So what does this gives me? it gives me 1.213 plus 3.75 plus 2.5 plus 2.5 volts, which is equal to 9.963 volts, approximately giving me 10 volts. All right, approximately giving me 10 volts. So this is the sum of all the potential differences in my circuit. All the potential differences in the circuit added together is this 10 volts. Now I have two batteries. All right, okay, so I have, let me say I have E equals E1 plus E2, which is 6 volts plus 4 volts, and that gives me 10 volts. Okay, all right, so you see that the sum of the EMFs is 10 volts. The sum of all the PDs, the potential differences, is also 10 volts. So we can say that E1 plus E2 is equal to V1 plus V2 plus V3 plus V4. So in an electrical circuit, the sum of all the electromotive force is equal to the sum of all the potential differences, as we can see. So I think this is a quick one. All right, so I think lesson 2 is just quick. So to follow this, you go to lesson 1, you quickly go through it, you come to lesson 2, and then that is the concluding part. I think this is just quick one, very easy and simple. So with this as a foundation, or with this as a reference material, you can be able to look at other questions and then try to apply what we've learned over here. I think it's going to be helpful. Yeah, it's a good material that we can always rely on. So a quick one, all right? Remember always, learning is fun. Let's keep learning. Let's keep enjoying what we know how to do best. That is learning and teaching. It's just fun. That's what keeps us going. And remember, until I see you next time, take care of yourselves and each other. Bye.